Hey everyone, Mr. Skelton here, back at it for the start of Unit 8, and today we are going to begin our lesson on sequences, and you may have some experience in this. I bet back in Algebra 1, your days in Algebra 1, you may have done some basic work with sequences and series, and we're going to continue with that today. And so today we're going to talk about just what a sequence is, and more specifically we're going to talk about what an arithmetic sequence is. This word can be pronounced arithmetic. That's usually how I say it. But you'll hear some other pronunciations of it. But it's an arithmetic sequence. And so what we want to do today is be able to do two things. We want to be able to write a recursive and an explicit formula to find terms within the sequence. And then we're also going to do a third thing, which is find arithmetic mean. And so you actually already know how to do this. We're just fancying it up a little bit with its name. So let's just jump right into it. This is an example of a sequence. A sequence is just an ordered list of numbers. I kind of put the vocab here right now. So 2, 4, 6, 8, 10, ... That means it's going to continue to go on. Each number is a term. So usually when I have a sequence here, I write the term numbers right above it, just until I get comfortable with this. So the number 2 is term 1. It's the first term in the sequence. The number 4 is the second term in the sequence. The number 6 is the third term. The number 8 is the fourth term, so on and so forth. As we get going in this lesson, we're going to create different kinds of formulas based off of what's happening to the term number, to the number itself, and vice versa. So it is important to know the information about the term number. So some of this stuff's going to be a little bit challenging for you just because of how it's written or how it's expressed. So what we're going to get into is a couple things right here. This is a sub n. A sub n. We say a sub n. That's how we would pronounce that, okay? Where n is the term number. So a sub, like in this example here, a sub 3. A sub 3 would be 6 because the third term in the sequence of a would be 6. If I said what's a sub 5? A sub 5, what is the fifth term? 1, 2, 3, 4, 5. The fifth term would be 10. So n represents the term number. A sub n is the term itself, okay? So we have two types of formulas, and this is going to occur within over this entire unit, really. We have what's called a recursive formula and an explicit formula. And it's very, very important you know the difference between the two. A recursive formula is based solely on the previous term, and it's not often used. More times than not, we're going to be using number 2, which is the explicit formula. But I will ask you to be familiar with the recursive formula as we go forward. Explicit formula is based on the term number. What I mean by that is, I always ask myself this question: what are you doing to the term number to get the term? Like, what am I doing to 1 to get to 2, 2 to get to 4, 3 to get to 6, 4 to get to 8, 5 to get to 10? What are you doing to those things? And so you'll see that as we go through. All right, so what I want to do is start with this problem, and basically what I want you to be able to do is come up with the next term. So this would be 1, 2, 3, 4, 5, 6. So the recursive formula, remember, is only solely based on the previous term of 10. And so what we would do here is we would write a sub n equals, since we are always basing it off the previous term, which is 10, we want to express that as a sub n minus 1. So if we want to find a sub 6, this is how it kind of translates, right? I want you to tell me what the sixth term is. Now you already know what it is. It's 12. We're increasing this by 2. But I want you to tell me what the sixth term is, writing a recursive formula. So a sub 6, the sixth term, equals a sub n minus 1. Well, what is a sub n minus 1? That would be the fifth term. Remember, it's always based off the previous term, so the fifth term. And then what are we doing to each term here? What are we doing? We're adding by 2, so plus 2. So the recursive formula for this problem, you would express it like that, and then you would fill in the numbers as such. So a sub 6 would equal, what's a sub 5? A sub 5 is 10, and then we just add 2 to that, so a sub 6 would have to be 12, which you already know. Okay, so that's an example of writing a recursive formula for this sequence. Explicit. So explicit, writing an explicit formula is based on the term number. In other words, what are you doing to the term number to get to the term? So what are you doing to the term 1 to get to 2? What are you doing to 2 to get to 4, 3 to get to 6, 4 to get to 8, 5 to get to 10, 6 to get to 12? We're obviously timesing by 2, right? And so a sub n for the explicit formula would just be 2n, okay? So if I wanted to find the, if I said, okay, what's a sub 25? What's the 25th term? We can do that real quick without having to do every single term, because you can't use a recursive formula to find the 25th term, because you would need to know the 24th term, which means you need to know the 23rd, 22nd, all the way down to 6. So that's why we don't use the recursive formula, because you always need the previous term. So if I said A25, we'd have to use the explicit formula, which would just be 2 times 25, because n is 25. So a sub 25 would just give me 50, and that would be my answer. All right, so there's a little warm-up on how we are using sequences. So again, we're talking about sequences. This is a sequence. It's just a series of numbers. And we have two types of formula, recursive and explicit. And a lot of the times we're going to be using the explicit formula because it allows us to find any term. I could say a sub 40, a sub 60, whatever. Okay? So that's just some basics. So now what we're going to get into are there's two different types of sequences. There's arithmetic and geometric, and today we're just focusing on arithmetic. So you see the definition there at the top. An arithmetic sequence has a common difference. We use letter D. We call it the common difference, which means it's a sequence in which to get to the next term, you either add or subtract the same number over and over and over. So it's not multiplying, it's not dividing. An arithmetic sequence is always adding or subtracting the same number over and over and over. So you are going to get these formulas, I believe, on a formula sheet, but this is the recursive formula, and this is the explicit formula for arithmetic sequences. All right? And you'll notice this one we kind of did on the one prior to this, right? So here we have an example. Let's just jump right into some examples, because that's always fun to do. So we have 13, 16, 19, 22, and 25. Again, I always label 1, 2, 3, 4, and 5. Okay? And I have two different sets of directions here. This one says find the 50th term, and this one says what is term number 256. So if I want to find the 50th term, now again, I'm not asking you to find the 6th term. If I ask you to find the 6th term, you would use the recursive formula. All other terms, like 50, we're using explicit. So if I want to find the 50th term, this is going to be a sub 50 equals a sub 1. It's the first term. So the first term would be 13. Okay? Now what are we doing to everything? You should be able to see real quick that we're adding 3 each time, right? We're adding 3 each time, adding 3 each time. So this is going to be plus, D stands for the common difference. That common difference, D would be 3 here, so plus 3, okay? Times n minus 1. Remember, n is your term number, so 50 minus 1. Now, you may be asking, well, why is it n minus 1? Well, if I want to get the second term, like 16, how many times did I add 3? I added 3 only once. If I asked for the third term, 19, how many times did you add 3 to get to it? 1, 2. So I went from 3, adding twice. If I wanted the fourth term, 22, how many times did I add 3? I added 3, 1, 2, 3 times. If I want the fifth term, how many times did I add 3? 1, 2, 3, 4. So you can see it's always the number minus 1. If I wanted the fifth term, I add 3 4 times, 5 and 4. If I wanted the fourth term, 1, 2, 3, 4 and 3. So that's why this n minus 1 is what it is. So a sub 50 equals 13 plus, basically what I'm saying, I'm starting at 13, I'm adding 3, how many times? 49 times. Take your calculator out, do it out, and you get 160. So the 50th term is 160. Okay? Now, if I asked you for what is term number 256, what is term number 256? So if I put in 256, okay, so 256 would go here, equals a sub 1 is 13, plus 3 and n minus 1. So if I, like this was a sub n, a sub 50 in this case, was 160. I'm telling you what it equals. I want to know what term number it is. So here we would solve for n. So I had minus 13. You can take your calculator out and go 256. We're going to minus 13. I get 243 equals 3 times n minus 1. So I'm going to divide that by 3, which is 81. So I get 81 equals n minus 1. And I'm going to add 1 to both sides, and I get n equals 82. So the 82nd term in this sequence right here is 256. Okay? The only problem I didn't do here is I did not ask you for the recursive formula to find the 6th term, but you could just plug that in and figure it out. Okay, the one on the bottom, this is just going to get repeated over and over, so what I'd like you to do is try this one on your own. Okay? I would like you to write the recursive formula for this and the explicit formula for this sequence, and then find these two things. Try it. Okay, we are back at it. So let's come up with the recursive formula for this. We got to figure out what's happening. What are we doing to each term? Looks like we're adding 2.5 to here to here. We're adding 2.5 here to here. We're adding 2.5. Just double check it. Yep, 2.5. So that's one term, second term, third term, fourth term, fifth term. So the recursive formula would be a sub n. So if I want to find, for example, the 6th term, I would go a sub n or a sub 6 equals the previous term, so a sub n minus 1, which would be a sub 5. And what am I doing? I'm adding 2.5 to that. And so that's how you would find the 6th term. I didn't ask you to find the 6th term, but that's how you would do it. It'd basically be 17 plus 2.5, which would give you 19.5. Real quick to use the recursive. Explicit formula. So explicit formula, again, what are we trying to figure out? We're trying to figure out a sub n. We're always going to start with our first term, which is 7. We're adding 2.5 to each term how many times? N minus 1. I start with 7. We're adding 2.5 to n minus 1 terms. Again, the n minus 1, if I want to find the 5th term, we added 2.5 how many times to 7? 1, 2, 3, 4. We added it 4 times to 7. So, yeah, you can memorize this, and I'll give you the formula sheet, but it should make sense to you as well. You should be able to understand why that is. Okay? So this would be our explicit formula for that problem there. So finding the 50th term, a sub 50 would equal 7 plus 2.5 to the 50 minus 1. And so we just take our calculator out and go 2.5. We're going to times that by 49, hit equals. And then we're going to add that to 7, hit equals. So our 50th term, a sub 50, should be 129.5. Okay? Second question over here, what is term 69.5? So I take 69.5, set it equal to 7 plus 2.5 to the n minus 1, and I'm trying to figure out what term number 69.5 is, so I subtract 7. So 69.5 subtract 7, I get 62.5. I'm going to divide by 2.5 on both sides, and I get 25, and then I add 1, and I get n equals 26. So what did we just figure out? The 26th term in this sequence, if I went all the way to 26, is 69.5. Okay? Flip it over on the back. Last question here. Same thing. Go ahead and hit pause and see what you can come up with. All right. Now, what are we doing here? This one's slightly different. What are we doing to each term? What did we do to 15 to get to 9? We subtracted 6, subtract 6, subtract 6, subtract 6. So this is the first one where we're subtracting. So our D, our common difference, remember, is a minus 6 here. So what's the recursive formula? So if I asked you to find the 6th term, what would it be? You'd go a sub n equals a sub n minus 1. You take the previous term, and then you add or subtract whatever it is. We're subtracting 6. So if I wanted to find the 6th term, it'd be the 5th term minus 6, which makes sense, which would give you negative 15. Explicit formula for this to find any term we want would be a sub n equals, what's the first number? 15. What are we doing to 15? Over and over again, we are subtracting 6 n minus 1 times. So that's our explicit formula. I want to find the 62nd term, so a sub 62 equals 15. I'm minusing 6, basically, and 62 minus 1 times. So a sub 62 would equal 15. And now in your calculator, I'm going to go 62, so it's basically 61, right? 61, I'm going to times that by negative 6. And I get negative 366, okay? And then I'm going to add basically 15 to that, and I get a sub 62 equals negative 351, okay? So the 62nd term in this sequence here would be negative 351. What is term number negative 171? So negative 171 equals 15. I'm subtracting 6, and I want to figure out what term number that is. Remember, that's n. So I would subtract 15. So basically negative 171 subtract 15 is negative 186. And then I'm going to divide by negative 6 on both sides. So divide by negative 6, and I get 31 equals n minus 1. And then add 1 to both sides, and I get n equals 32. And so what does that mean? That means the 32nd term, 1, 2, 3, 4, 5, 6, all the way to 32 would be negative 171. All right, the very last thing, you already know how to do this, so I'll go very quickly here. Arithmetic mean basically just means finding the average of two numbers. Remember, arithmetic means adding or subtracting, which is D. We call that the common difference, right? The common difference. So basically, to find the arithmetic mean is just finding the mean of two numbers. All you're going to do is take the two numbers that are given to you here. So I'm basically asking you, what's the arithmetic mean between negative 52 and negative 128? You would just add these together and divide by 2. So it's basically average. Negative 52 plus negative 128 equals, divide that by 2, and you get negative 90. And that's the average between those two. Now, the only way we can get this a little bit more challenging is, you see 3 spaces here, so I need all 3 numbers. So in my mind, I'm thinking, okay, here's 27, here's 71. I can find the arithmetic mean to go there. So 27 plus 71 divided by 2. 27 plus 71 equals divided by 2. Gives me 49. So this number is 49. And then I can use that 49 now and find the middle ground here and here. So 49 plus 71. 120, so that's going to be 60 divided by 2, right? And then I got 27 plus 49, and then I'm going to divide that by 2, and I get 38. Okay? And so that's arithmetic mean. And that's it. I think that's it for the notes. Okay? So, again, just recap. Introduction to sequences. Again, a sequence is just an ordered list of numbers, and we talk specifically about arithmetic, so we're adding or subtracting the same number over and over and over again, right? And we call that D. We call that the common difference. You'll see that over and over again. I know I've written it multiple times, but that's what we're doing. Recursive and explicit formulas. You got to know both of those. If you have questions in class, I'd love to help you out. Take care.